Namaste friends, we are in the wave motion topic. I hope you are following the wave motion content. Today our goal is to learn about the types of wave motions, or it we name it as the types of waves by motion. So the waves are categorized in the two types depending upon the motion of the wave particle. There are the two types, one is the transverse waves, another one is the longitudinal waves. So there are the two types, one is the transverse waves, another one is the longitudinal waves. Longitudinal waves, there are two types, transverse waves and longitudinal waves. Let me begin with the transverse waves. What is the definition of the transverse waves? Means the wave in which the individual particles of the medium oscillates perpendicular to the direction of the wave propagation. So that means let me take the water waves, so you can easily understand. Water waves will be formed like this. So will you please, the water wave is propagating like this. This is the wave propagation direction. This is the wave propagation direction. The water wave, the medium, the particles of the medium, they are oscillating like this direction and like this direction. See, the wave direction is like this. This is the wave direction, but the particles are oscillating exactly perpendicular to the propagation of wave. They are oscillating exactly perpendicular to the propagation of wave. Here is the 90 degrees is there. Here is the 90 degrees is there. That's why that wave is named as the transverse wave. That means the wave in which the individual particles of the medium oscillates perpendicular to the direction of the wave propagation is called as a transverse waves. What are the examples? Examples is nothing but it is the transverse waves. So it is so the transverse waves example is the water waves. Water waves are the transverse waves, and also electromagnetic waves, EM waves. EM waves are the example for the transverse waves. Now while the particles are oscillating, it will form the two positions. One is the crust they will form, another one is the trough they will form. So we need to know what is meant by crust, what is meant by trough. Before going to that, see, the one complete crust and trough can be called as a one wave. It is named as a one wave. One wave means the one complete crust and trough, the adjacent crust and trough. So one complete crust and adjacent trough can be called as a one wave. Now let me go to the what does it mean by crust. Will you please look on this one? The crust is having, it is the maximum displacement of the particle in upward direction in the transverse wave. So the crust is nothing but it is the maximum displacement of the particle. It is the point where the maximum displacement point is occurred in positive direction or upward direction. What is the trough? Trough is nothing but it is the maximum displacement of the particle. Maximum displacement of the particle, it is the point where the particle having the maximum displacement in downward direction, it is called as a trough. So will you please look on this crust and trough definition. So the maximum displacement point in upward direction is called as a crust. The maximum displacement point in downward direction is named as a trough. So in the crust and trough, the transverse waves, they will produce the crust and trough. Let me go to the longitudinal wave. So in the longitudinal wave, there are the waves in which the individual particles of the medium oscillates along the direction of the wave propagation. So let me take the longitudinal waves examples are sound waves. You can take the sound waves. These are the sound waves. They will come very closer. They will form the compressions and rarefactions. This is the point of the compression. This is the point of the rarefaction. Compression and rarefaction. They will form the compression. So to form the compression and rarefaction, the particles are oscillating like this. They are oscillating like this. They will come closer and they will move away from the mean position. So the wave is propagating like this horizontal direction. The wave is propagating like this horizontal direction. The particles are oscillating in the same direction. See, the particles are oscillating in the same direction. They are parallel to each other. They are having the parallel to each other. That means in the wave in which the individual particles of the medium oscillates along the direction of the wave propagation, that wave is called it as a longitudinal waves. What are the examples for the longitudinal waves? They will examples are the sound waves. Sound waves are the examples for the longitudinal waves. So the longitudinal waves can transfer through the solid. It will transfer to the solid and liquid and gases also. They will transfer solid, liquid as well as the gases. But what about the if you observe this longitudinal wave will propagate through the liquids only. They will propagate through the liquids. Here they will propagate through the liquid. So they will propagate to the liquids. So the transfer waves and longitudinal, these are the points for the longitudinal waves, the types of waves. I hope you understand. What about the transfer waves? Transfer waves, the propagation of the particles is up and down. The wave propagation direction is having, so they are perpendicular to each other. In the transfer waves, in the longitudinal waves direction, the propagations is the horizontal to the propagation of this wave direction. That is the very important for this one, longitudinal wave and transfer wave. These are the two types of waves. Thank you for listening. Thank you.